Hi, welcome. So this video is for the very first lesson of the trimester for 1.02 Graphs of Systems. So I am not here today on March 14th. So this is your recording for this lesson so that you can still do the exit ticket today. So here we go. So our learning targets for this lesson are: I can solve a system of two linear equations and two variables by graphing, and I can classify a system of two linear equations in two variables. There needs to be an S right there. Okay, so here's this picture I have right here, and this is my learning target. Get it? Because it's like a target. Okay, so on the outside level is a confused level, and so this is where you're thinking this is new to me or I don't understand yet. So since I don't actually see you guys today, it's going to be kind of difficult for you to fill this out, but when I see you tomorrow, March 15th, I'll ask you to place a cursor. It's totally anonymous, a cursor on the level that you think you're at. And so these are the different levels. So if this is completely new to you, then you are in the confused level, which is okay. The developing level is the second level in. This is I still have questions, so I need some help. That's that developing level. The confident level in the middle, I understand and can do this by myself. So that's the confident level. Then the expert level in the very center of the target is I understand and I can help my classmates. So if you feel at the end of this lesson that you are at the expert level, that's awesome. Even if you've moved in one level, that's awesome. That's great. So that's our learning target, and you'll see that every time we meet. So get used to putting a cursor here. Okay, so let's talk about systems of linear equations. So here's an example. Mrs. Shang has two batches of bamboo plants that she will use to make a fence. The first batch grows 2 feet per week and had stalks that were 4 feet high. This second batch grows 1.5 feet per week and had stalks that were 7 feet high. Will the stalks ever be the same height? So the first thing you need to do is write an equation for each batch. So the first batch goes 2 feet per week and had stalks that were 4 feet high. So this is 2 feet per week, so X is weeks, plus they were already 4 feet high. So that's the first batch. The second batch grows 1.5 feet per week and had stalks that were 7 feet high. So 1.5 or 3 halves, X plus 7, where X is weeks. Okay, so first you write those equations, and then basically what you do is you graph those two lines. Okay, you graph those two lines. So here's that first equation right here, 2x plus 4. So I start at 4 and I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1 until I get there. Second line, I start at 7 and I go up 3 over 2. That's why we wrote it as 3 halves. Up 3 over 2, up 3 over 2, up 3 over 2. Okay? And where they intersect, that point where they intersect, that is the solution. So the solution to this system of equations is the coordinate point, which is a solution to both equations. So this is the point of intersection. So this has a point of intersection of 6, 16. So 6 is our x-coordinate, 16 is our y-coordinate. X-axis represents weeks, and then y-axis represents height. So this tells me that at 6 weeks, they will be the same height and they will both be 16 feet high. That's what this intersection point is telling me, because it's 6 weeks, 16 feet high. So now what you need to do is check, because sometimes our graphs can be imperfect and we can get a weird answer. So to make sure our answer is actually correct, we plug it in to both equations to see, do we get the same thing? So we're going to plug in 6 for x and 16 for y. So here's our first equation. So what we're looking for is the same number on both sides of the equal sign. Excuse me. So 16 for y, 6 for x. 2 times 6 plus 4 is 12 plus 4 is 16. So this one works for that equation. Let's plug it into this equation and make sure it works. 16 for y, 6 for x. So 6 divided by 2 times 3 is 9. 9 plus 7 is 16. So it works. So that's how you graph systems of equations. So let's do some more examples. So 2 or more equations in the same variable create a system of equations. That's just the definition. So 2 or more equations in the same variable. If all the equations in this set are linear, then the system is a linear system of equations, which makes sense. If they're all lines, then they're a linear system. Okay? So here's an example. Find the solution to the system of equations below by graphing. then show algebraically that the coordinate is a solution to both equations. So we're going to graph both of these lines and then find the point of intersection. So I'm going to grab my pen and we're going to graph. So the first equation, y equals negative 1/2 x plus 2. So I'm going to start at 2. I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. All right. And then I can keep going. So now I'm going to insert my line. I know this looks kind of weird because it's not actually. Okay, so there's the line. I can extend it out this way. I'm going to make it a black line. There we go. So there's my first line. All right, let's do the second line now. All right, y equals 2x minus 8. So we're going to start way down here at negative 8, but we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Oh, looks like they intersect right there. All right, let me insert my line. And we can make it a little bit longer. And we'll make it a black line to make it easier to see. Okay, there's our two lines. So we graphed both of those lines. Now we need to find the intersection point. Looks like the intersection point is right there at 1, 2, 3, 4, 0. So our intersection point is, 4, 0. So check algebraically that the coordinate is a solution to both equations. We're going to plug it in. So this is our x and this is our y. So we're going to go 0 equals negative 1/2 times 4 plus 2. So 0 equals, well, negative 1/2 times 4 is negative 2 plus 2. We get 0 equals 0. So that works for that first equation. Let's do it for the second equation. So that is this one here and this one down here. So 0 equals 2 times 4 minus 8. Well, 2 times 4 is 8 minus 8, and 8 minus 8 is in fact 0. So it works for both equations. All right, and that's how you check algebraically. All right, let's do this one. So solve the system of equations by graphing and label its solution. So you may notice that these are in standard form. You need to change them into slope-intercept form, or you can use intercepts. But what I'm going to do is I'm just going to change it to slope-intercept form because that's easier. So we'll change this first one here. So first thing I'm going to do, so slope-intercept form, in case you don't remember, is mx plus b. We want y by itself. That's our goal, is to get y by itself. So I'm going to subtract 8x from both sides. So I'm going to get 6y equals negative 8x plus 48. Divide by 6, divide everything by 6. So negative 8 over 6, I can reduce that down to negative 4 over 3. And then 48 divided by 6 is 8. So there's our first one. I'll do the second equation in a different color. I'll do it in this purple color. So this one's going to come all the way down here. So I'm going to subtract 2x from both sides. So I get negative 3y equals negative 2x minus 6. Divide everything by negative 3. So I get y equals, negative divided by negative is a positive, so 2/3 x plus 2. There's our two equations. Okay, so let's go back to our first one and we'll graph that one in black. So I'm starting at positive 8, going down 4 over 3, down 4 over 3, down 4 over 3. Okay, and let's insert our line. We'll use this guy here. All right, make that a black line. Now let's draw our other line. This one's purple. So we're starting at positive 2, and we're going up 2 over 3, up 2 over 3, up 2 over 3. All right, and let's draw our line. Same line. There you go, and we'll make this one purple. Oh, maybe not. Well, we can make it purple. There we go. All right, so we have both of our lines graphed. So our intersection point is right there. And so that intersection point is 1, 2, 3, 4. Our intersection point is 3, 4. So that's what they mean by label the solution, is tell me what the coordinate is. All right, so that's how you can change those into slope-intercept form and graph them. So let's do one more or a couple more together. So check for understanding. Which graph represents the solution of the linear system? So you're going to look for a slope of -2 on one of the lines with a y-intercept of 2. And then this one, if we change it to slope-intercept form, it will be a slope of +2 and a y-intercept of -6. The only one that makes sense with a slope of -2 and a y-intercept of 2 is this one right here. See, none of these intercept at 2. So that gives you a hint right there. So the only one that makes sense would be graph A. So graph A is the solution. All right, so sometimes, I only have 15 minutes to do this, so I gotta make it go really fast. So a system with no solutions is an inconsistent system. This would occur when the lines are parallel and never intersect. So inconsistent would be this guy right here. No solution, because the lines never intersect. A system of linear equations is consistent if it was exactly one solution or infinitely many. So a consistent independent system is a consistent system with exactly one solution. So this middle one right here is a consistent independent system. One solution, because they intersect, and you can find that intersection point right there. Consistent dependent or coincident, we'll just say consistent dependent, is a system with a consistent system with infinitely many solutions. So notice there's two lines here, but it looks like the same line. That's because they're essentially the same line. So this is a consistent dependent system with infinitely many solutions. And like I said, since this is a video, you can always ask me for help in understanding these. So let's go ahead and identify system. What type of system is shown below? So there's two parallel lines here. So if we go back and look at our notes on parallel lines, these two lines are parallel. So this is an inconsistent system. So the only one that makes sense is inconsistent, okay? Because they're two parallel lines. All right, so every day after class, after the lesson, you'll have this self-reflection side. So you'll tell me how you're feeling, and you'll place a cursor on the target depending on where you are after the lesson. And so your job today, no matter what, even if we don't meet, is to go through all parts of the lesson. So if you still need help, make sure you read through the lesson and do the exit ticket. Come to the help session tomorrow. It'll show up on your schedule. Have a great day. And here's some extra practice problems, so you can pause the video and write these down here. And then there's also these ones right here. Okay, so you can go ahead and pause the video and write all these down. I'll come back to these ones. And you can pause the video right here. And then here's also the other set. All right, so I will see you guys tomorrow.